Hey there, have you ever thought about creating auto-generated objects, characters, or levels in your game in Unity? Well, today I'm going to show you how easy it is to auto-generate objects, even for a beginner. We'll start by just auto-generating an object. We'll move to randomly selecting objects while auto-generating. We'll build a wall, and we'll use some assets that require special rules while auto-generating. We're going to see some bugs that we all run into, some of the humorous effects those bugs can cause, and how to fix the bugs so that we get our desired results. At the end of the tutorial, we'll take a quick look at my game Touch Maze. Its levels are auto-generated, so we'll quickly look at the code and the final result. The techniques you'll learn today will give you a base that will allow you to use auto-generation in your games. Let's get started. All right, okay, we've got Unity open. I've just got a blank scene. I think I'll create a new one. I'm in a project from a previous tutorial. We're just going to expand on that. So we'll create a brand new scene here, and we'll call this auto generation. And we've switched to it now. All right. So the first thing we are going to need an object that we want to auto generate. So let's create a floor first. We'll create, I'll just use a cube, and we'll make that centered around the 0, 0, 0, and we'll make it large. So we don't have to worry about edges. Oops. We do not want y to be 100. There we go. And we'll just change the color so that the white isn't hard to look at. So let's create a new folder called materials. And in materials, we will create a material, and we'll just call it floor. And we'll just select, let's do a gray. So right, go back to our cube, drag the material onto the element, and there we go. Okay, now we already have a camera and a light, so let's just figure out where the camera is so we can position our objects appropriately. All right, so let's create a ball. 3D object sphere, call it ball. Once again, we'll center it along that 0, 0, 0. Except this time, instead, we will have it the height of 8 so that it'll be falling for us. We will add a rigid body to the sphere. Has gravity enabled. If we save it now, go back and view it, we now have the ball crash down. But it doesn't bounce. I think since the goal of a lot of this is just to have some fun, let's make this bounce. It'll make the interactions later in the tutorial a lot more fun. How do we do that? We go into our materials again, and we create a new physics material. We'll just call it bouncy. Okay, so we've put a value of 0.9 on the bounciness. That means that it will lose a little bit of energy when it bounces. We need to apply this now to the ball. So we can apply it in the rigid body, in the sphere collider under material here. So now if we save it and we play, we've got a ball that bounces. Okay, so this is the object that we are going to auto-generate to begin with. How do we do this? Well, the first thing we need for auto generation is a script that will do the generation for us. So we'll create a empty object here. We'll call it auto generation controller. We're going to go into our scripts folder. I've got a move controller script from my last tutorial. We want to create a new script, and we'll call this auto generation controller. So this will auto generate a start and update function just like we always do in Unity. Look and see it on the right here. We want to apply that code to our empty object here. We do that by adding component, type in auto generation controller, and you see the script, and we add it there. Okay, so we've added our script. Let's go into Visual Studio. We will open our Solution Explorer and open the auto generation controller. And as we saw, there's a start and an update function. These comments really don't do much for us, so we'll remove them. We can see that Visual Studio is telling us we're not using these using statements right now, so we'll remove those. And the first thing we need to do is pass the reference of our object that we want to create automatically back to our code. And we do that, if you saw my previous tutorials, you'll just recognize this. If you've used Unity much at all, you recognize this. We want a serialized field. We want it to be private. We want a game object, and we're going to call it uh, underscore the ball prefab. So when we save that and Unity compiles the code, we will now get a space in here called the ball prefab that we can put a reference to our ball. Now I purposely named it prefab here because I think that's the best way to do this. We'll go to our prefabs, we will grab our ball and we'll drag it in there. So now everything that we've done to our ball up to this point is in this prefab. And because we're going to be auto-generating these balls, we can go in and remove the one that we had added to the scene. The only thing left to do in Unity here now is to go back to our auto generation controller, find that field again, and drag our prefab over into that field. All right, save that now. And now let's go back into Studio and we will create one of these. So I'm going to start out for the first part here. As I said, step one is to create one of these balls. Let's go and create a private bool. Oh, private bool is ball auto generated. Make it false. And we're going to use the update function. A reminder that the update function runs once every frame of the game. So we're going to say if not is ball auto generated. First thing we'll do is set that to true, and then we were going to create an instance of this ball. In the function to do that in Unity is instantiate. And we pass in the ball prefab. That's all it takes to create an object from code in your game. And because we set up the prefab, and that prefab is set in a certain spot in the game, we are able to predict exactly where it's going to be created. So let's let Unity compile that, and we will run it. Oh, we've got some compile errors. Let's go check what those all are. So apparently I can't type. We've got a private book here. It's supposed to be a bool. Okay, so we let Unity compile this, assuming we have no errors. We can run it. And this is where we get the ball. Same thing that we had before. But now that we have this reference into the back, into the code, we can now start playing with this a bit. I originally had set it up like this so that we only get one, because if we didn't test for this, we would get one per frame, and that would be pretty insane. So let's start creating these through time. Let's create a way that we can create a ball every few seconds, let's say. So the first thing we're going to do is we're going to undo the bool that we just created. We need to get rid of that variable as well. And so we're going to need to have two variables to be able to generate these after a certain amount of time. So we'll call it private float time between object generation. And we've set that to 2.0f for now. F, of course, denotes float. And private float time since last object generation. And we're going to set that to 0. And what I'll do is I'll write the code first, then we can explain what it does. So the first thing we need to do is say if the time since last object generation is greater than the time between object generation, then we want to instantiate. And we also want to reset time since is equal to 0. And then we do an else. We go time since last generation plus equals time dot delta time. Okay, what this is doing is saying if the time since the last object generation, which we've set to 0 to begin with, is greater than the time between object generation, to 2, so this would fail to begin with. When it fails, it comes thrown and adds time dot delta time to that variable. Time dot delta time, is, as a reminder, is the interval in seconds from the last frame to the current one. So that variable will continue to grow until it hits the 2.0, in which case we then instantiate the ball and we reset to 0. So this should have us in Unity, once it compiles, have us generate a ball every 2 seconds. Now, one of the odd things about this is going to be, as you'll see, that these balls stack on top of each other. Obviously wouldn't happen in real life, but we can fix that. The way I'll just quickly handle it here is that when we generate, we're going to move the position of the sphere just slightly over so that it isn't exactly stacked on top of each other, and that will get the desired effect that I'm looking for. In order to do this, we are going to change the instantiate function, the ball prefab, dot transform dot position plus random dot on unit sphere times 0.1f. So the random.onUnit sphere returns a random point on the surface of a sphere with a radius of 1. We're multiplying it by 0.01 to make it effectively 10%, or sorry, 10% of the original size, and we're adding it to the position so that each time that this is generated, the ball position is going to be adjusted slightly. And it's going to be in a random direction anywhere around the sphere. And then we use the quaternion dot identity to denote no rotation. So this is an instantiation of an object at a position and no rotation on the object. So now if we save this and go back into Unity, get every 2 seconds the ball falling, and you can see now we're getting some bounces and some interactions with the balls. We've been putting these parameters up here. We've got 2 of them right now. The reason that we call these out and not do something like this in here is that these things are called up to the top and are very easy to locate. If we decide that that 2 seconds for auto generation was too slow, we can change it to 1 second very simply, and then the code will do its magic and we'll have these balls falling more often. So something to keep in mind when you're doing this stuff is to bring parameters that affect how these things are changing to the top so that you can adjust them as you go. Now we are generating these balls. Let's put a second object into the mix here. So we're going to do the same thing here. I'm just going to rename this cube to floor. And we're going to create a new cube. And again, we're just going to leave it, well, we're going to position it at the 0, 0, 0, so it's the same spot as that sphere. We'll put it at a height of 8 as well. We'll save it. We need the rigid body for gravity. And let's hit play and see what we've got. Now, our square there, you can see obviously fell first because of it being in the Unity tree, but let's get that into the auto generation as well. So we are going to do the same thing. We're going to our prefabs. We'll drop our cube in. We will go back into our code. I'll just do a copy paste and call this the cube prefab. Okay, so it's here that we need to change. We want to decide between the two of these, and let's do it in a random fashion. So we're going to need a random number generator. So far, random number generator is equal to system.random. We need the new keyword, of course. Now, one of the things with random is that it has one overloaded method called, it allows you to insert an optional seed. If you don't specify the seed, the system will use a seed based on time, and that'll be effective for what we want to do. So we'll just leave it at that. And we want to go var random number is equal to random number generator.next. So we put this in saying we want a random. Let's make that spelling mistake. There we go, no more random numbers. We have a random number generator.next between 0 and 2. The way this generates, this is not inclusive, so this will give us either 0 or 1. Then we do a statement to test. If our random number is greater than 0, then we will instantiate sphere. Otherwise, we will instantiate cube. And we can use the same parameters here. We want the cube to be created. We want to have it also moved in a slightly different direction, and we don't need any rotation. So let's save that. And just for fun, we will change this to half a second. So once again, when this compiles, oof. Well, something's obviously not going right here. So we can see an error in the bottom. This is a pretty amusing error though. I can tell even before I click what's going on. We didn't move our prefab into the um, into the field in Unity, so it's throwing a null exception error. But that was pretty entertaining. It's one of the fun things about this is that sometimes you can get some pretty funny stuff happening when you make a bit of a mistake. So what we need to do, we've got our prefab. If we go to the code again, we need to drag this in here. So that will get rid of that error that we saw. I'm going to remove the one that we have in the tree just because it's not needed. And now if we go back to the code, yeah, it should be fine. I think everything else should be fine. So let's, oh, this is why we need an else. That's a little bit more like we were expecting. And you can see now these are randomizing which one we're getting. Oh, we're getting a stack and then it'll fall over. All right, cool. So, I mean, this is fun. This is, we're auto-generating objects. This is absolutely the basis and the basics for what you need to start on auto-generation. But obviously, this isn't helpful unless you're looking to make a mountain of mess here. So let's move on to trying to do a bit more coordination when we're auto-generating. So we're going to take this cube that we've got here and make a wall with it. So when we want to do that, We're not going to use the update or the start function. Generally, a lot of the time when we're doing auto generation, we want it to happen before the level is created. And so we want to use a function called onEnable. This function happens obviously before a lot of other stuff happens, and that way you can create these objects, put them in your scene, and then when the scene starts, they will be there. So let's do that. I'm going to just leave the the code in the update, and it's kind of fun, and we'll just keep working over here. We can use a lot of this code again. Um, we need a few more things as well. So we're going to do add another function up here called private vector 3, and we're going to call it initial position for generation. And we're going to create a new vector 3, add all the zeros. So again, we're just centering it to where the camera is. And what we want to do, very similar to here, is instantiate a cube prefab, and we are going to use the initial position for generation. Okay, let's just save that there for now. Go back into Unity and just make sure that we've got what we want. We'll see when we start that we'll have a cube at the bottom. You can see it was kind of half in the floor and then got pushed up, so we can fix that. So let's just make this 1. Okay, so we'll just put the y coordinate of that at 1 and see what we get here. All right, there we go. And now we have everything following it. That's fine. What we want to do now is create a bunch of them in a row. So we'll do that in a loop. So I declare the loop int I is equal to 0. I is less than, let's just say 10 for now. It's got it for me. What we want to do now is keep track of where the next one should go. And so we want another variable called private vector 3 next position. To begin with, we want next position is equal to initial position. Okay. Then we can instantiate the one that we did in our loop. And we just need to update our next position. So we want to go next position is equal to, and we can do a plus equals, a new vector. And in this case, we're going to move the next one over 1 unit because the cubes are all 1 unit in size and width in the x direction to start the wall. So we'll go 1.0f, and the other directions we don't want to have anything. Okay, let's see what we've got now. And we have an explosion of stuff. Clearly the two close together and are on each other when the scene starts, and that's why you get that explosion. So let's take a look and see why it was doing that. Okay, so if we look at our code, it's pretty simple to figure out what ended up happening here. We've got the instantiate using the prefab for a cube, and is using the initial position for generation all the time. It's not supposed to use that, it should use the next position. So we'll put that in, hit save. And there, we've got a wall now. And we've got cubes and balls on the wall. You can see there's some things happening. The physics still works on those, so it'll be interesting when we build this wall up to see what happens. So let's in fact do that. Let's build up. So for now, we'll just use another loop. And let's go to just a 10 again as well. We'll make it 10 by 10. And we want to put this loop in here. Okay, so what we'll do is move this into this loop so that each time that we set the position, we're going to reset it back to the beginning. And then we're going to apply a vertical movement based on the loop variable. So the first time being 0 will stay on the bottom. And the next time being 1, it'll be 1 level up, 2 levels up, etc. So we want to go next position is equal to, and now we need actually a new variable here. And we'll go private vector3, and we'll go vertical movement for wall. And then this will be, it'll actually be the same as the one before because this is we don't want it to be negative though. It's a 1 by 1 by 1 cube. Okay, and we want to add that vertical movement. So we need to add it to it. So we want to go plus equals to that. And this should be times j. Okay, so we now have this loop that for each row in this wall of 10 by 10, we're setting the position that we're using back to the initial 0, 0. Then we are increasing the level. You got a spelling mistake there. We're increasing the vertical position for the wall based on the number of loops it is. So each row, each time it goes through the loop, it'll do a row on top. And then we instantiate the wall just as we had. So let's go and look at what this does. Okay, we've got a wall, and now with the random things coming down, we've got parts of it coming down. There's ways to fix that, whether the wall is coming apart like that. Let's do that. In fact, first let's just take the camera and position it so that we can see the wall a bit better. So let's just tilt the camera up a bit. So I added a -10 rotation to the camera just so it looks up a little bit. We'll just see if we can see. There we go. We can see it a little bit better. The whole thing's shaking there. It's gonna kind of terrible. It's a terrible wall, but obviously the auto generation piece worked. We can fix this if we want to. What I'm going to do is duplicate the prefab for the cube, and I'm going to rename it wall. And on that one, on the rigid body, we're going to use as kinematic. This just means that outside forces cannot move the object. And then in our code, we need a new variable. We'll call it the wall prefab. And we'll just change here that we're only using that. So now the cube is made for the dropping auto generation where the wall is now generating the wall. So let's check what this does now. Clearly have an error. And it's the same error we had before. We need to make sure that we're passing our prefab back to the code. Right there. Hit save. And there's our wall. It is no longer tumbling. And we still have our objects getting created in the middle of the wall there. That's kind of fun. Okay, now while this is an okay wall, it's a little bit boring. So let's try and add a bit of color to it. So let's duplicate the wall. We'll call it wall 2. And what we need is to change its color. So we'll just go back into materials. We'll create a new material. Let's just change it to some random color here. Yep, let's make it bluish. That's good. And then we need to go back to our prefabs, select our new wall, go to our materials, and we'll drop the material onto it. So now we have a blue wall. We add another variable. So we add another variable, wall 2. Before I forget anything, I'm going to go back into Unity and make sure I assign that object. Okay. And then we're going to do the similar to down here. Okay, so we've got the same code as we had. We've added the random number generator. We're generating a random number between 0 and 1. And we are instantiating either one wall or the other depending on that random number. So if we save that, we go back into Unity and play this out, we should now get a two-tone wall. There we go. What if we wanted to add a third color? So this is where it starts to get interesting, and I think it starts leading into more what most people would want to do with the auto generation, because you want to have multiple options. So what do we want to add a 3? We could just add the wall 3, but the list would get unmanageable if you start getting 20, 22, 23, whatever it is that you're wanting to do. So instead, we are going to change this to have an array of walls. So we'll copy one of these and we'll call it the wall prefab, and we'll have an array. Okay, if we go back into Unity, we can set this up. First things first, let's create the third wall. Just want to duplicate. So let's set its color to something different. So we'll need a new material. You can just duplicate this. We'll make this one green. Okay, so there's a green that we can use. If we go back into our prefabs, select our new wall, we can change the color of it. There we go. And then we go back to auto generation control. So the new thing here, and it hasn't added it yet, so let's go see what happened there. Obviously that's the wrong spot. You need to add that there. So let's call it the wall object. And it's an array of game objects. So if we go back into Unity, we'll have this array here. We can now add our 3 options. And we go back to prefabs. We've got our wall, wall 2, and wall 3. Okay, good. Now if we go back into our code, obviously this is going to have to change, because right now we're based on a random number selecting 2. We want to do the same with selecting 3. So, I mean, obviously the answer that would make this 3 here, But again, we want to try and make this more future-proof. We want to make sure that if we are expanding this to more, that it'll automatically happen for us. So we can use the wall objects dot length, so that if we increase to a fourth, we don't need to come back and change our code. Then, instead of testing what the random number is, we can use what the random number is in our array. So we can delete all of that, and we can instantiate, instead of the wall prefab, it'll be the wall objects at the random number position. And we can save. So with that little bit of code now, we can get the third in there. Okay, let's just see what those changes did. And there, we can see now we have 3. Now with the code that we've just written, it is extremely simple to get the 4th in there and the 5th. If we duplicate this again, and instead of green, let's duplicate that. I don't know, we'll just make a random one. Let's just do that kind of reddish tone. Go back to our prefabs, new wall, materials, new color on, save. Now all we need to do now here on our auto generation controller is add a new element to the list, add the new prefab. Oops, we didn't add it. Oh, we did. I missed it. Right there. Save it, and we don't have to touch code this time. And our new colors are in there. Now again, this is still, I mean, if you want to make a wall like this in your game, obviously that's great. So let's look at something a little more realistic for, say, well, at least the games that I've been making. We've got in here my fantasy interiors, and in there I've got prefabs for other walls. So let's do that here. I've got a cathedral wall here. If we put this onto the scene, then we can just, again, let's go to 0, 0, 0, and we'll snap it a bit so we can see. You can see it's just like a stone wall. We would like to use this object to generate our wall instead of cubes. So how do we do that? Well, it's actually quite simple. If we go to our prefabs and we drag this wall into here, it's already based off a prefab, so I'm going to make a new one, and we'll just call this stone wall. Okay, and then if we go back to our auto generation controller, remove all of these elements, and then replace the stone wall once again without changing anything. We'll delete this one. Without changing anything on the code side, it will handle having this generate based on that array. Now, obviously, there's some weird stuff going on there. So let's figure out what's going on. So in this case, we've got the identity, rotation identity, having the problem. The prefab itself has rotation, so we're now getting reset here. So we need to change this around a little bit to be able to set the rotation that we want to have with these types of walls. Okay, so we need to create a variable to store what we're instantiating, so we'll call it the generated object is equal to, and then we don't want the full instantiation, we just want to end it there. Then we need to move it to the next position like we had before. And transform is what we do. Generated object.transform.position is equal to next position. And then, actually, that should probably just do it. Okay, so I have set the position of the rotation back to 90 here on this stone wall. And when we run it, we get a stone wall basically the same size as what we had. What's interesting with this prefab is that, of course, we're still using ones to denote the next position, whereas I know based on the game I'm writing that these walls have a height of 3 and a width of 2.5. So let's go change our code to handle that. And again, this is why we have all of these things up as in parameters up here instead of hidden in our code. So we're still good with the initial position for generation, but we want the vertical wall movement to be 3. And look at what we're doing it down here. We've got a vector for next position. That should be a variable. So we should do this here. Private vector underscore horizontal movement for wall. And in this case, we want the 2.5, 0, 0. And we can then now change this to a variable as well. Okay, let's see what that looks like. Compilation errors. Missed a semicolon. Okay, so we have it here. Now, maybe you would want a wall like this, but I think what we'll do now is we'll kind of take off the vertical building, go to keep the horizontal building, and we want to introduce other pieces so that we can write the code needed to choose between what's next and what's not. So let's get into that. So we want another prefab of a wall piece. We want walls and cathedral walls. We're going to do this corner here. Now we can see when we go in here and we rotate it, I'm going to just center it at the same spot as usual. I think what we'll do is we'll turn it around to this, nope, 180, yeah, just to align with the wall. So we're going to use the straight piece and this piece to build a wall continuously. So we need obviously to have that at as a prefab. We'll add this to the 0.5, oops, to put it on top, and we will add it to our prefabs. Rename it to stone wall corner. Now we do know that we can delete the one that we created. That we obviously want to add this into our array here. But we also know that with what we've got, actually this will probably be pretty entertaining too. This will build a wall with some of these pieces jutting out of it. So obviously this is still working. This is definitely not what we're looking for though, but it's another step ahead. So if we go into the code, the first thing we'll do is we'll take out the loop for height. We still have our next position set to the initial position for generation, and we still have all of this randomness here. So we'll save it up and we'll look at it. So this should now just give us one level of wall, and it should have us have random pieces in it. What we'll do now, just we'll move the camera a little bit again. There, we'll just move it a little bit so we can see more of the wall. Let's just make sure it's there. Move it a bit more would be fine. Okay, so let's get back into the code. We need to create rules to tell us what can happen after each piece. And to do that, we're going to set up a few things here. First thing we're going to do is I'm going to create an enum that will help us when we are referencing our wall types. We're going to have one called straight. We're going to have one called right corner. And we're going to have one called not selected. Then we need a dictionary. And it's going to be a dictionary of wall type to wall type array. Now this is a bit strange. Let me explain. This dictionary is a list of all of our wall types with an array stored with it of what kind of wall types can happen after this one. So, for example, for wall type dot straight, we'll create an array of, well, we want wall type right corner and we want wall type dot straight. So this is saying when we are going to use it that if our current one is a wall straight, then the next one should be either a straight or a corner. So let's create a couple more of these to define what the other two wall types do. If our wall type is right corner, well, after a right corner, we want a straight. There might be times, obviously, where we're not going to do this, but for the purpose of this demonstration, we'll just have it set to that. That if we have a corner, we're just going to do a straight after that. And then the last one is a no, not selected. And we'll just have it as a straight as well. Basically, what this is going to have is not selected is to handle the first instance. Okay. The last thing that we need is another dictionary. And this is a dictionary of wall type to game object. And this is going to be called wall type to game object mapping. Now we can't instantiate it here because we want to use the objects in this array, but we can do it just before on the on enable. So we will go wall type to game object mapping. It's equal to new. We can just use the short form of instantiation, and we want a wall type straight is going to be the wall objects at 0 and wall type dot right corner maps to the wall objects at 1. Now, notice by doing this, we have eliminated our flexibility with being able to add objects in the Unity editor and have our code completely work for us. There would be ways to be able to continue that automation. This part of it is more to figure out how to write some rules around the auto generation. Okay, so now what we want to do, we've still got our loop of 10. We need to know what the wall type is as we're looping through here. So we need a variable for that. We will call that private wall type. And we will call it's the current wall type. And we will start it at wall type dot not selected. So then we still need the random generator, but we'll do this. We'll go var next wall type choice is equal to wall next block for the current wall type. So that gives us the array. So that's going into this dictionary and pulling out one of these arrays of what the next block could be. So then we were going to do, we're going to take this random number generator out of the for loop. It shouldn't have been in the for loop to begin with. We are going to go var next wall type is equal to the next wall type choice at random number generator dot next the next wall choice dot length, and we want to instantiate now the next wall type. Now I'm going to save that. We are not quite done, but we want to see what this does. There are compilation errors. So obviously the error here is that my next wall type is in a num. It is not a game object, which is why we built the wall type to game object mapping. So we need the wall type to game object mapping for the next wall type, and that will instantiate the game object we need. Save that, go over to Unity. Okay, we're only getting the straight one, so clearly we're not doing everything we need to do. Let's take a quick look at the code. Yes, of course. We have not set the current wall type. So we want the current wall type is equal to the next wall type. And now we should be okay. Go back into Unity and look. Okay, so we're now getting the random changing between straight and right. Of course, the wall isn't moving the way it should. That'll be the next thing that we tackle. So this is a rule in this specific instance that when we have a right corner, we need to move the wall location over 1 unit. Well, in this case, it will be 2.5 units. Okay, so in order to be able to do that, we're going to need another, instead of the vertical wall movement, we need one for the right corner. So I'll just call it that. Probably can come up with a better name, but and instead of in the Y direction, we want it in the Z direction, and we will do a 2.5F. Okay. We then need to apply that if we have if the next wall type is equal to wall type dot right corner, then we know that the next wall block needs to be moved 1 unit over, 1 unit being 2.5 float. So we need to move the next position variable that way. Next position plus equals the right corner move for wall. And we'll save that. Let's go see what that did. we've it had the desired results just in the wrong direction. So let's go make that change. It'll need to be a negative 2.5f. Okay, and now we can see our wall being built. Again, this is a pretty simple example, but you get the general idea of being able to set rules for all the different pieces that you've got, what can follow next, and what can be placed and where it needs to be placed. So the last thing that I want to bring in here is that decorations. Obviously, those want to be randomized as well when you're auto-generating some of the stuff. So let's bring in another prefab in from this interiors package I have purchased. Let's bring in a candle. So let's get into props and lighting, wall mounted. So if I bring this in, I've used this one quite a bit. It's like a wall mounted candle. Let's make it a prefab here. And actually what I want to do, if I bring in the prefab here, what I want to do, I'm just going to drag in one of these walls here. And I would like to move this to be a child of the wall, have its position set to 0, 0, 0. I want this to be that. And then we need to move it closer to the wall. And so it looks like negative 1.15. Save it. Okay, so we've got that now. We will need to create a prefab from that. We will call it wall candles. We need a reference to that. As usual, I'm going to delete what I'd created. We need a reference to that in here. Save it back into Unity to assign it before I forget. Then we are going to put these only on straight pieces. So we've already got a test in our code for if it's a right corner. So we'll put in an else if next wall type is equal to straight. Oops. Then we obviously don't want it every time. Let's do another random generator. If random number generator dot next. So for random number generator dot next between 0 and 2, spare and 0, we want to create this instantiate candle prefab, and we want to set the parent, set parent to the we want to set the parent to the one that we just created, which is the generated object. Set parent to generated object. Now the key for this one is, oops, dot transform, is that we want to say false to world position stays, because we had just set up this prefab to work well with this being a child of the stone wall. So let's take a look at what this does. Okay, so we did get one at the beginning there. Let's try again and see if we get more. There's 1 second there. What I'm going to do is position the camera again. I'm going to move it up a bit. Move it, rotate it 90 degrees, and see if that gives us a better vantage point of, well, actually we won't right now. You can see some of it. Let's actually move it over a bit like so. Okay, let's actually even move it higher. So if we go up to 20 and we look down a bit, okay, I'm actually just going to move it a bit back this way a bit. And then the other thing we'll change is, let's change this to 50. And this, of course, will take it right off the cube that we made as a floor. But we have a wall that's being randomly generated at runtime. It has rules for what happens after straight piece, after a right corner piece. It has a random chance of having a candle on the straight pieces. We can add other wall segments in with rules of their own to be able to handle it. We can build up if we need to. We can add roofing if we need to. We could add flooring if we need to. All it would take is the logic needed, just like we worked out for some of this. And so in my released game, Touch Maze, I've used the techniques that I've just shown through this tutorial to generate each level of that game. You can see I've got those game objects for some of the different things. I've got a lot of the parameters that we talked about. I've got a dictionary of right here. So we've got that same enum for my maze blocks. I've got a dictionary for the game object lookup, and I've got a next block dictionary. And so you can see that in this case I was a little more complex because I had a level of where we were in the maze. So if you've got a ceiling straight piece at level 0, then the next one can either be a ceiling up or a ceiling straight. And so I had this next block override as well. There was a couple instances where I needed to override, but those are some of the rules that you need to create as you're building your game and building the rules for your auto generation. And then again on the enable, I've got a loop here to start with 5 that 5 blocks where we just create 5 at the beginning, and then a for loop as well for the total number of blocks I needed for each maze. Okay, so if we go into Steam, I can just do a quick run of this and show you the result of the code we just showed. So again, here are the 5, that loop of 5 here at the beginning is this first straight track, and then we can start getting into the auto generation at the end here. And just rules is what defines this. The next time we try this, if I can see it, crash, and retry, we now have a different and we'll just do one more. And we can see it started the same, but it went way up to the top here. So you're interested in checking out Touch Maze, it's available on Steam as well as on Android. Yeah, go check it out. There you have it, auto generation. Thanks for sticking with it, and well done. The techniques that you've learned today should give you a base to allow you to use the auto generation in your games in Unity. If you're looking for more Unity tutorials, then please subscribe. I'm going to be putting more out, and I will link to another one here. I also am working on my game, Ortunia Mysteries. It's an escape room style game, and I am putting devlogs out on both Instagram and YouTube. Again, please subscribe if you're interested. Now, go out. Use auto generation in your games. I can't wait to see what you're building. Chat soon.